All right, it is time to execute problem 66. We basically want to add 1. So we have, but basically we're just adding 1 to a number, but the number is represented as an integer, or no, as a list. So instead of being 123, it would be a list of 1, 2, and 3, and you just add 1 and you get 1, 2, 4. But then you have to account for carrying things over. So if you have just 9 and you want to increase by 1, then it becomes 1, 0 because 9 plus 1 is 10 and you have to create another digit. Okay, so this is pretty straightforward in terms of the approach, because you basically the approach is straightforward. It's just a matter of making sure that you get the code right, and the approach is simply just going through the way that you would do it if you were doing it by hand, where you start at the least significant digit and you increase by 1 and you carry over if needed until you get to the end. So it's important to think about that. So remember when we do this by hand, if you're doing just a sort of grade school math, then you start at the very rightmost point. So we're going to have to loop through this array from right to left, which we don't normally do. And then the other thing is we need to think about sort of what the carrying over process looks like. So basically, if you get to a digit, if you're trying to add 1 to a digit, but it's a 9, then you carry the 1, meaning that the 9 becomes 0, and then you increase 1 to, or then you go to the next highest significant digit and increase that by 1 instead. And so what you can do is you can write this as a loop in which you sort of loop from right to left, and you just increase, you try to increase every digit by 1. And if you have a digit that's like every time you run into a digit that's less than 9, then you just increase it by 1 and then you're done and you can return the array that you end up with. But if it's a 9, then you have to set it to 0 and then go to the next lowest index and then try to increase that by 1. And then you keep doing this process. And then if you get to the very end and you have an extra 1 that needs to be carried over, then you just create a new 1 at the very beginning of the array. Okay, so to make the notation easier, by the way, again, I'm writing this by hand because it helps me think, and I like to do it. Okay, so n is going to be the length of digits, so this is the number of digits that we have. Right, and we're just going to loop. So for I in range. Okay, so now again, we're looping from right to left here. So we want to start with the last index in digits. And so n is the length of digits, and so the indices of digits will be 0, 1, 2, all the way up to n minus 1. So we're going to start at n minus 1, and because we're counting down the indices, our step is going to be minus 1. And then the place where we need to end, so the last index we want to consider is the last index in digits, which is 0. And so we want to end at 0. And so the last thing we put here is minus 1. Because, again, when we're using the range function and we're specifying the end, the range will go all the way up to the thing before the last number. So that's sort of like how range of n will go up to, range of n will have the integers from 0 to n minus 1. This as well will have the integers from n minus 1 by increments of -1 down to 0, because 0 is going to be the last index that you hit before you get to -1. Okay, so again, we're just going from right to left, and as soon as we get a number that is less than 9, we just increment that by 1, and then we're done. So if digits I is less than 9, then we simply take digits I and we increase it by 1, and then we're done. We can just return the resulting, return the resulting list. Okay. So if digits is not less than 9, if digits I is not less than 9, then it has to be equal to 9. And so in that case, we want to carry the 1. So we're going to set that 9 to 0 and then carry the 1. So here we're going to put digits I is equal to 0. And like what you could do like else digits I equals 0, but the else is not necessary, because if this if statement evaluates to true, then it's going to exit the loop, because it's just going to return the function. So it's going to exit the function because it's going to return this list. And so basically, if we get to this line of code, it has to be the case that this is not true. And so we don't have to worry about the else statement here. Okay, so otherwise, digits I is going to be equal to 0. And yeah, then so then we're going to carry that 1. And what the carrying the 1 means is that we just go to the next lowest index, which is I minus 1, and we try to do the same thing there. We try to add 1 to that. But that's taken care of by this for loop, because once we get past this line of code, we're going to start back at the beginning, and we're going to take I and decrease it by 1, increment by -1, however you want to think about it. So this is all we need in our loop, because it's automatically going to go to the next lowest index. All right, and so then what we have at the end here is return. Okay, so now this code that I'm writing, this is assuming that we've gone through this for loop and the code is still running. That means that this return statement has never been activated, which means that every digit has been equal to 9 and thus replaced by 0. And so that means that the original array digits had all 9s in it. And so what we want to do is we want to just return. So it had all 9s, and so what we want is we just want 1, and then all those 9s replaced by 0s. So we have 1, then we're going to add 0, and how many of them do we have? We have n of them. And so, by the way, so you could either do it like this. You could return 1 plus n zeros, or you could just simply do 1 plus digits. Because remember, at the end of this, assuming that we get to this line of code in the first place, at the end of this loop, every single index in digits was 9 and was switched to 0. And so digits at this point in the code, it already contains entirely 0. It already contains n zeros. And so we can just put a 1 at the beginning of it. Okay, and so this is the code that we need for this problem. So let's go and try to actually implement this. So n equals digits. Cool. Let me figure out how to type. Okay, and for I in range, we're going to go n minus 1, and we're in increments of -1 all the way down to 0. Okay, if digits I is less than 9, then we increase it by 1, and then we're done. Okay, otherwise, we're going to set it to 0 and keep going in the loop and try to increase the next significant digit by 1. Okay, so then at the very end, if we're at this point in the code, then we just return 1 plus digits, because the fact that we get to this point means that digits was all 9s, and it has been switched to all 0s, and so you just add 1 in front of it. Okay, and then we submit this, and there we go. So there's our solution. A pretty straightforward problem, and yeah, so we're just able to blaze through it. So there we go.